And this is where we left off, and this is the stuff we were just doing in that game, where we are trying to do a couple things. Some of them we're converting. So, taking these, for example, if we want to take 3 to the negative second, when we put that in log form, that is equal to -2 equals log base 3 of 1/9. Okay, and you guys did a nice job with that. Going the other way, if we have the common log of 1 equals 0, remember, of course, common log has base 10. Its equivalent is 1 equals 10 to the 0. So that was, kind of a summation of the first thing we did in our last class. And then the second part was evaluating. So, for example, log base 4 of 2 means 4. So what power equals 2? Well, the square root of 4 is 2, or 4 to the 1/2 power is equal to 2. So today is going to deal with logs, but it's going to deal with expanding and condensing different logs. I shouldn't say different logs, or log functions together. And there are 4 rules that are up there, and I'm going to really focus on the first 3. And first is the product property. And these will make much more sense as we do examples. Okay, but here's how you want to, I think, try and remember that when you have a log with a base of 2 things multiplied together, when you expand them, you can expand them by doing log of the first plus the log of the second. And the key is that the multiplication becomes addition. In a similar note, if you have 2 things divided, division becomes subtraction. Okay, and without getting too deep as to why is that, it's kind of crazy that multiplication becomes addition. Remember, logs and exponential functions are inverses, so they live by the same rules. For example, if I asked you, and you don't have to write this down necessarily, but if I said, what is x squared times x to the 3rd, your answer would be x to the 5th, because we would add those exponents. Similar kind of rules, okay? When we're multiplying 2 exponential functions, we add the exponents, and that's why the multiplication becomes addition when it comes to logs. Same thing if I asked you x to the 5th divided by x to the 3rd, that equals x squared because we subtract the exponents. So we're kind of following those same rules. So addition, or multiplication becomes addition, division becomes subtraction, and then the third power property is that if you have log of some base of x to the y power, that y in front, that y that is the exponent, can be written out front. So we can write that as y times log base a of x. So I'm going to focus on those first 3 rules and try and show how can we write each logarithm in terms of the natural log of 2 and the natural log of 3. So to do these problems, I have the natural log of 6. I have to think, well, how can I make 6 from 2 and 3? Well, I know 2 times 3 is 6. So I would think of this as the natural log of 2 times 3. But I can expand that using this first product rule as the natural log of 2 plus the natural log of 3. So now I've rewritten the natural log of 6 in terms of natural logs of 2 and 3. All right, to do part B, I again have to think, all right, how can I make 2 over 27 with the numbers 2 and 3? Well, I would think of it this way. Think of it as the natural log of 2 over 27. Isn't that 3 cubed? Okay, so again, those powers of numbers are really important. Because now using the quotient rule, I can subtract those two things. But I'm also going to sneak in the power property as well. So when I expand this, it would be the natural log of 2 minus 3 natural log of 3. In fact, you know, I skipped a step there. I'm going to move that down one. Maybe I did a little much in that. What I did was the natural log of the top, which was 2, minus the natural log of the bottom, which was 3 cubed. So I first used that quotient property to make the division subtraction. And then I took that 3 as the exponent and wrote it out front. And so that 3 of that exponent is that 3 that's written out front. All right, let's keep rolling here, do a couple more. Now we want to write these in terms of, for problem 2, we want to write them in terms of common log of 3 and common log of 5. So how do I get 75 from 3 and 5? Well, 3 times 5 is 15. So, you know, that's not 75, of course. But I know 3 times 25, so you have an idea? 5 squared times 3, excellent. So if we thought of this as the common log of 3 times 5 squared, 75 is 3 times 5 squared. Then when I expand that, the multiplication will become addition. That 2 is going to become an exponent, I'm sorry, a coefficient. And so that would be the common log of 3 plus 2 common log of 5. All right, let's try that next one. So I have to make 9 over 125 somehow powers or multiplication or division of 3 and 5. I know that 9 is 3 squared, so I can think of that top as 3 squared, and the bottom is 5 to the third, right? And so I can think of this as the common log of 3 squared over 5 to the third. Again, I'm thinking that as common log of 3 squared over 5 to the third. So now when I expand that, the division becomes subtraction. The exponents are going to become coefficients. So that would be written as 2 common log of 3 minus 2 common log of 5. 3 common log of 5. Thank you very much. 3 common log of 5. Sorry, I can't read my own handwriting, because that is 5 to the third, right? All right, any questions yet? I'll keep C. We'll come back to C. Okay, it's kind of an odd one. But let's go down to the bottom where there are variables. Now, I guess my first hint or first suggestion would be don't freak out from the variables. Typically, you'll find those easier than the numbers as we move along. I'm going to expand this all in one step. I'll write the answer, let you digest it for a second, and then I'd be happy to explain any of it, okay? But I have three parts to this. I have, the 5, the x to the third, and the y. So I'm going to write this as log base 4 of 5 plus, because they were multiplied, 3, that 3 is going to become a coefficient. So 3 log base 4 of x, and then plus log base 4 of y. And that, one step, is my answer. Again, just take a peek, digest that for a second. Again, the 5 is my log base 4 of 5. That x to the third is the middle part. The 3 became the coefficient, so log base 4 of x. And I had a plus, and then plus log base 4 of y because I was multiplying that. All right. Questions on that? Okay, I'm kind of throwing a lot at you with those 3 rules here. So please feel free to ask questions if you have them. Slide that guy over a little bit. Let's do part B. Okay, I have really 2 parts. I have this top part here and the bottom part. So I'm going to subtract. That division is going to become subtraction. I'm thinking the square root part, that is a 1/2 power, which is going to become a coefficient. So this would be it would be 1/2 the natural log of 3x minus 5 minus the natural log of 7 plus the natural log of x. All right, digest that for a second. I'm going to take one more step and distribute the negative. But before I do so, Olivia, you have a question?
Where did the 1/2 come from?
Yeah, where did this thing come from, right? Great question. That came from me thinking of this numerator as this 3x minus 5 to the 1/2 power. So remember that the square root means to the 1/2 power, and since that was an exponent, that 1/2 then became a coefficient. Yes? Yeah, why did I separate the 7 and the x in the bottom into this? Because remember, 7x means 7 times x. And so then that multiplication, I want to separate as many things as I can. That multiplication can become addition as natural log of 7 plus the natural log of x. So I'm using that first rule to separate. That's kind of like 7x. And so my 7 was here and my x was there. All right, good questions. I'm just going to distribute the negative sign. That's not a big step. But our final answer should be the 1/2, sorry. 1/2 the natural log of 3x minus 5 minus the natural log of 7 minus the natural log of x. All right, that's a lot to take in. Are there any questions yet? Other questions? Those have been good so far. Yes.
So why wouldn't you have to put 3x minus 5, the natural log of 3 plus the natural log?
Yeah, good question. So why I split up this 7x into this guy, why did I not split up the 3x into natural log of 3 plus natural log of x? And the reason I didn't do that is because this is all one chunk. And because of the -5, I can't split those up. Okay, good question. Anything else? All right, well then let's go the other way. Now the answer is given, and now we want to write the problem, so to speak, or we want to try and condense into a single log. So as I look at this first problem, I see a coefficient and I'm thinking, okay, that's going to be an exponent. I see an addition and I'm thinking, okay, that's going to be a multiplication. So I also have this 3, that's going to be an exponent. So I'm going to write the answer down here, but I can fill in like the steps in here in just a second. So this is going to be as one log is going to be the common log of the square root of x times x plus 1 to the 3rd power. That big ugly thing is our answer. Now I left plenty of space in here to try and explain, but I want to let you guys look at that for a moment. So this part, that 1/2 became the exponent, so that became common log of x to the 1/2. And this is where that guy came from. Then I had this 3 and x plus 1. So that was the common log of x plus 1 to the 3rd. And so this is where that guy came from. And because it was plus, I just wrote them as multiplied together. Yes. Yeah, so the question was, is it, you would not do that to answer your question. What you said is, do you do log of this times log of that? When you condense it, remember this, it is condensed to a single log. So you're not multiplying both logs. When you write log, if you do it correctly, it is condensed. You are only writing one log. Okay, so it is a single log that you are condensing into, not two parts. Okay. Yes.
Does the x have to be square root from x to the 1/2?
Yeah, so I probably would accept x to the 1/2 because those are the same. It's preferable to write it as the square root of x, but I would get what you're saying there. Okay. You guys are asking good questions today. All right, how about if you guys try part B real quick, and then I'll put the answer up in just a second. Okay, part B, we have natural log. I see we have a coefficient, so that too is going to become an exponent. So that's going off of my head. I see a subtraction, that's going to be a division. So as I combine these into a single log, it would be the natural log of quantity x plus 2 squared, because of that guy, divided by, because of that, X. That would be our answer. Yes, yeah, so if you wrote log base E of that, it would be correct. But you really should get in the habit of writing that as ln. Okay, I mean, just, this is considered better mathematical notation, but you're totally getting it if you did it this way. Anything else? Okay, so these rules are big, and we only focused on the first 3 rules. We're not really going to get into the number 4. Don't worry about that. But what we did is we just converted, changed things where we were taking a number and trying to write it in terms of certain logs. We then, using the variables, we expanded, and then we condensed into a single log.